Now that we've shown that the derivative with respect to x of the natural log function is precisely 1 over x, we can now find derivatives of more complicated functions that involve this natural log function. Let's go ahead and do that. Here we have for the function f the natural log of the sine of x. We have a composition of functions, and in order to find the derivative of a composition of functions, we need to use the chain rule. So we've got the inside function is the sine of x, the outside function is the natural log of that. So the chain rule says in order to find the derivative of a composition function, you take the derivative of the outside function. The derivative of the natural log function we saw is 1 over x, but instead of evaluating it at x, you evaluate it at the inside function. So instead of 1 over x, we're going to have 1 over sine x. And then, once we've taken the derivative of the outside function and evaluated it at the inside function, we still need to multiply by the derivative of the inside function. And the derivative of the sine function is cosine. Hence, we have here that the f prime of x simplifies to simply cosine x over sine x, which is by definition the cotangent function. Let's now find the derivative of this composition of functions. In this case, the natural log of x is the inside function. Taking the sine of that is the outside function. So we've got g prime of x is equal to the derivative of the outside function. Derivative of sine is cosine. So we have cosine of, and instead of evaluating it at x, you evaluate this function at the inside function, meaning we're going to take the cosine of the natural log of x. And then we need to multiply by the derivative of the inside function. And the derivative of the natural log of x is 1 over x. Hence, g prime of x is precisely the cosine of the natural log of x all over x. And we've got one more example here. You've got the function h of x is equal to the square root of the natural log of x. Remember that taking the square root of something is equivalent to raising that to the 1/2. So this is the natural log of x, that quantity raised to the 1/2 power. In this case, we have a composition of functions again. The natural log function is the inside function, and then the square rooting or raising to the 1/2 is the outside function. So h prime of x is going to be the derivative of the outside function, which is a power. So we bring that down front and drop it by 1. So we'd have 1/2 and drop that power to negative 1/2. However, instead of evaluating this at x, we evaluated it at the inside function, which is the natural log of x. And we still now need to multiply by the derivative of the inside function, and the derivative of the natural log of x is precisely 1 over x. Let's now clean this up a bit, and let's write it so that you no longer have a negative exponent. Of course, this would bump into the denominator as to a positive 1/2 power, and then I'm going to also rewrite that back in root form. So we have h prime of x is equal to 1 over 2x, that's this 2 and this x, and then times the square root of the natural log of x in the denominator. Here are 3 examples where you use our newfound derivative, that the derivative of the natural log function with respect to x is 1 over x within the use of the chain rule.